Okay, so I guess you might be sitting there quite excited that you're going to get all the answers that you've ever wanted about aphids in canola and armyworm. And I guess one of the things that I want to stress is that this research can be quite a slow process in terms of getting threshold data. Some of the stuff that Hugh's talked about in that earlier presentation had probably taken him close to 10 years perhaps to refine those thresholds to a point where he has a high level of confidence. So essentially what I'm going to do today is just talk a bit about some of the underlying understanding that we're trying to get a handle on in order to progress some of this threshold work. And I'm hoping that what I've got to tell you this morning is really going to give you a better understanding of what's going on in the paddock, if not the answer. So in terms of armyworm, we had an opportunity to look at armyworm this year in northern New South Wales. There were some quite high populations, and I guess we were particularly interested because the threshold that's available for armyworm, which is a nominal threshold, a fixed number, 7 heads lot per night, and you work out your crop loss from that. The basis or the background to that threshold is completely unknown. Nobody knows where that threshold has come from. So our interest was in validating that, or at least having a look to see whether it held up in the field. And I guess these are some of the take-homes from the work or the monitoring that we did this year. And the first is that, contrary to the theory that you might read in any recommendations about managing armyworm, is that if you have large larvae, you will have head lopping, and certainly that didn't hold up this season. The other thing that was really apparent in calibrating the sampling methods is that if you're not doing a ground search, you're severely underestimating the numbers of those critical the critical life stage, which is those medium and large larvae, which are the ones that will potentially cause damage. And the threshold, I guess, at the end of our work, because of some difficulties with actually getting these things to behave in field trials, is that we really haven't had an opportunity to validate that threshold. Now, the threshold, does anyone want to have a go at what threshold they would use in barley, for example, with armyworm? Something in the vicinity of 2 to 3 larvae per square metre, is that ballpark? If you actually use that nominal 7 heads a night per armyworm and work out what the cost, from your costs of control and the crop value, what your thresholds are, you can see in that table that it's substantially lower than 2 to 3 per square metre. And I think that, that in itself, to my mind, is quite a concern, given that, a lot of people would have an experience of having numbers higher than these numbers in their crop and still not get significant head lopping, if head lopping at all. And that just reinforces for me that this 7 heads and 2 larvae per square metre definitely needs some investigation to get a good handle on it. So what did we see this year? And some of the crops that we monitored, these were the sort of larval numbers if we averaged them at their peak. So you can see that they're exceeding any threshold that you might see promoted by quite a significant amount. And the other thing that we did was we followed these crops, and each time we looked at them, we took some plant samples and we looked at how much damage there was. We also looked at the amount of defoliation, because at one point, as the flag was coming up, there was some concern about the impact of potential defoliation on those upper leaves. But the thing that, one of the things that we looked at was the number of heads lopped and the number of heads showing any sort of damage, and you can see that by and large it's relatively low. The one crop amongst the group of crops that we monitored that did get sprayed, you can see they were running, this crop did look particularly ratty, and you can see that we were seeing damage to awns, etc. But, the interesting thing to me is that in those fields, even with those densities of larvae right through until the crop matured, we saw no head lopping. So there's something else going on in that relationship between armyworms and the crop. And talking to Gary McDonald, who did his PhD back in the 80s on armyworm, you can see why all the detail doesn't get included in thresholds, because what he said was that there's some other trigger that they can't put their finger on that results in armyworms head lopping. So he's seen barley crops that are green have their heads lopped. He's also seen barley crops like these situations go right through without head lopping. So I guess in the absence of a definite threshold, my take home from what we saw, and I guess from some discussion with the agronomist, is that monitoring is critical, and including not only larval numbers but also a fairly good investigation of what they're actually doing in the crop and whether there is actually damage accumulating. I suspect at this point, when we haven't a better handle on the relationship between numbers and the potential to headlop, that actually monitoring damage, which is a normal part of what you do, is probably equally as important. The other thing that we noted is that the defoliation of the flag and other leaves on the plant, the amount of defoliation was not related to the density of the larvae, so there's not a linear relationship between larval density and the amount of defoliation. So defoliation is not a good measure of the damage potential, I don't think. So just to sampling, and all I want you to take away from this graph is that we calibrated the beat sheet and the sweep net, because the sweep net has been traditionally the method with which any discussion about thresholds is the basis for that. So threshold sampling, a sweep net sampling is what the threshold is based on and derived from the southern states. What we did was we compared what you would find if you used a beat sheet or a sweep net in the same field. And this is just one of the fields that we looked at as an example. And the important thing is to take away is that early in the season, when there were small larvae, you can see that there's a big discrepancy in what you will find using a beat sheet and a sweep net. The beat sheet and the overriding take home is probably that across the board, and if we look down here, that tells you the beat sheet is more efficient in dislodging those larvae from the plant. And when you get bigger larvae, there's not much difficulty in dislodging them from the plant, so there's not a big difference between the beat sheet and the sweep net. But in terms of looking at how the population's developing, certainly the beat sheet is superior in giving you a bit of a heads up on what's happening with the population in terms of the small and medium larvae. And I mentioned before in the take-home messages that ground searches are essential for getting a good handle on what's going on, and this is just an example from another one of the fields. So the blue, what we did was we sampled with the beat sheet and we counted what we got, and then we sampled the same metre of row to look at what was on the ground that we would have missed. And you can see here that when we're talking about small larvae, the beak sheet's doing a pretty good job. The majority of those are up on the plant. It's when we get to these medium and large larvae that you can see the contribution of a ground search really improves your estimate of what's actually there. The other thing about the reason I put in these pre-pupae and pupae is just in understanding what's happening to that population. What you tend to see is that you'll see larvae there and then they start to disappear, and I guess it's important or comforting to know what's actually happening to them. Are they dying from parasitism or predation, or are you just not sampling them today for some reason, or are they actually going through and starting to pupate, so that that sort of information, I guess, reinforces your confidence in making a decision about what might be necessary in that field. And certainly, neither the beat sheet nor the sweep net will give you any information about what's going on here in terms of pre-pupae and pupae going through. Just in terms of mentioning beneficial activity, there was a lot of beneficial activity this year, and that's quite typical of populations of insects that are particularly high. Some of the things that we saw that were pretty common is this multiple parasitoid here. I guess in terms of larval parasitism, which is the one that has an impact in terms of potentially preventing crop loss, we didn't see anything higher than about 20%. Pupal parasitism in some fields was higher than that, but that's not particularly useful in a pest management context. So just to say that there is parasitism there, there's also predation that we couldn't measure, and they all contribute to suppressing those populations, and I guess interesting to know that it's going on. So The other thing that I guess has been causing some angst in northern New South Wales and southern Queensland with the increasing number of canola crops is aphids, and just the general uncertainty about how applicable those thresholds are that are available. The thresholds that say something along the lines of 20% of racemes infested is the threshold. And I guess some uncertainty about how you use that, knowing that those populations are very patchy, they're quite variable across the field, and also the complexity of actually getting too much further off the road into the crop to make an assessment of what actually is going on across the crop rather than just on the edge where we know that aphids predominate. We have had a go at, and I think NGA and GO have also had a go at doing aphid management field trials, and they're incredibly difficult because as soon as you get a good population of aphids, you also get a fantastic population of natural enemies, which makes it impossible to maintain those. So after having a few goes at this, we decided that our only option to look at the interaction between the sort of damage that aphids do and the crop was to go to simulated damage trials. And that's what we did this last season, and I guess that's what I'll talk to today. Where canola's grown, these three species, just quickly, probably the one that most are familiar with is this species that persists right through to the late through to late season. And turnip aphid, you may see earlier in the season, tends not to persist as the temperatures increase. And the one to keep an eye on, and I guess perhaps as we come further north, not a big issue, is green peach aphid. It tends to be an early season pest for us, perhaps in the vegetative stage. But in Western Australia, where it persists, it's a major problem because it brings with it a whole range of resistances to SPs, OPs, and carbamate. So that would be pretty much anything that you'd put into a canola crop would fail to control this species well. So it's worth keeping in mind in terms of canola control if you ever have a failure to consider whether this might be part of the reason. So the impact of aphids in canola can be twofold. This one down here I think is still a bit of an unknown, and YOP is doing some work on that presently in conjunction with some of the other plant pathologists. So I won't say anything about that, but in terms of the direct feeding damage from aphids, it's very apparent that they cause some impact on those flowering racemes, flower abortion and reduced pod set. There's a question about the impact on oil quality or content in those affected racemes as well that we don't have a handle on. So what is the overall impact of that sort of damage? There's very little literature available for us to draw on other than that preliminary work or that early work that was done in the late 80s, 90s in Western Australia that generated these thresholds. And I guess I would have some questions about the direct applicability of those thresholds developed in West Australia to the system that we're working in now with changes, different growing environment, different varieties now, and I guess some changes in crop agronomy as well. So one of the trials that we did was to attempt to simulate what you would see in the field with those late infestations, the ones that get sprayed most often. And this was the result. We basically removed the terminals, the flowering terminals of racemes. So in racemes like this, we basically took off those flowers and removed any potential to put on any more yield. And you can see that it didn't matter whether we removed 10, 50 or 90% of those, we saw no significant decline in the yield. And the question, I guess the question of why that might be the case. The other thing we did was something much more severe, which was targeted at what might happen if you had a much earlier and heavier infestation. As you go further south, this is not unusual. And we took off all the flowering racemes or flowering racemes to different extents. And you can see it wasn't until we actually took off pretty much all the flowering racemes that we got a significant decline in yield. And those plots were looking, in comparison with the controls, were looking like this after we applied those treatments. So what's going on? Why are we not seeing, particularly in that first trial I described where we took off those terminals? And I think it comes down to what's actually happening in the crop. And this is data from Canada, the only data on the crop physiology in this that described what was going on. And essentially what we're doing is we're treating aphids in this part of the flowering, or the flowering and podding cycle, long past the period in which you would set viable pods. So those flowers that are being protected are flowers that would never actually realise pods that end up contributing to harvestable yield. That said, I think that we're let down, or we're sort of managing in the dark a bit here, because we don't have a good handle on what sort of data we would generate here if we did these experiments to generate this data for this growing region. And I think that, you know, until there's some good crop physiology understanding of how canola grows and the interaction with frost and moisture and temperature, we're in the dark a bit as to refining our aphid management. And it's not quite that simple, as you all know. There are some other things that go on that you know, we've only scratched the surface of, in terms of things like the impact of natural enemies and Helicoverpa and how you might manage those two species together. Are there any questions? Happy to answer them. With the armyworm, for example, you know, there's no doubt that when the damage happens, it happens quite quickly, and if you check it on a weekly basis, it can be caught out. So I guess what we're trying to do is to bring a little bit more understanding to that risk assessment, you know, and I guess my sense, having not been through one of those really damaging armyworm infestations, was that if you have armyworms, you are going to get head lopping. And I guess, you know, as you explore that a little bit more, you realise that no, that's not the case. That if we can actually pin down what it is that makes some seasons highly likely to result in head lopping, then, you know, it's a risk management thing, that you can discount some seasons as being seasons in which you can be perhaps a little bit more relaxed, and other seasons where you might shorten those sampling intervals to make sure you don't get caught out. So I guess that's the approach that we're trying to take now, is to provide more information that will enable you to make a decision about whether the risk is so high that you do spray, because you might come unstuck if you don't get your sampling or you're monitoring it right, or if the risk is lower, that you can actually hold off or watch again. And I guess, you know, the effort that we're putting in with doing workshops and so on for growers is also to educate them in understanding that, you know, the risk is not always high. And if you understand how the pests work, the sort of things that Hugh says about, you know, the threshold is not a cliff unless it's a quality threshold over which you fall, that sort of understanding that, you know, insect pests in your crop is not an emergency situation, that, you know, we understand what they're doing and how the damage might be accumulating. So I think it's a long road we're going down before there's that level of understanding that will give us a bit more, you know, sort of give and take on the different pests.
Now, barley crops, we see a lot of lacewings floating around. Do they have any impact on armyworm numbers?
Not as far as I'm aware, and this is one of the big unknowns, is those natural enemies or those beneficials that you see in the crop, what are they actually doing? If you're seeing lacewings, are they, you know, exactly those questions. Lacewings, and that's, you know, we're looking at some of that, you know, if offering lacewings things like healy eggs or armyworm eggs or aphids, to see whether they have a preference. But in terms of understanding what they're doing, we only have really sort of a very basic understanding of which of those beneficials are actually doing what and how much of it they're doing. So, you know, the questions that we're getting asked increasingly is, how do we know how to factor the natural enemies that we're seeing in the field into our sampling? And particularly with aphids, how do we know if we've got, you know, 5 lady beetles per raceme, whether they're going to bring that population under control or if we're still going to have to spray? So, I mean, important questions, but really early days in terms of our understanding.